Ever wonder what makes one computer feel faster than another? Well, it's not just about the raw speed. It's really about how its brain, the CPU, intelligently juggles dozens, sometimes hundreds, of tasks at once. Today, we're going to break down the 6 key metrics that reveal the secrets behind this scheduling magic. So, let's dive in. You know that feeling, right? You walk into a bank, you grab a ticket, and then you just wait. That feeling of time just slipping away while you're stuck in line? That is the perfect way to understand how your computer thinks.
It might sound a little weird, but every single program running on your computer, we call them processes, goes through that exact same cycle. It shows up, it waits its turn, it gets its work done, and then it leaves. This little bank analogy is going to be our guide for everything that follows.
Okay, so let's make this official. In our little story, you, the customer, you're a process. The bank itself, that's the whole computer system. And that really busy bank teller, the one doing all the work, that's the CPU.
So every customer or process that walks in the door brings 2 key pieces of information with them, even before they get in line. We're going to call these the givens, because they're the starting point for everything else we're going to measure.
It all begins the second you walk through those doors. The clock starts ticking. You've officially entered the system. And in the world of computing, this exact moment has a very specific name.
We call this the arrival time. Now pay close attention to this definition, because it's a point in time, not a duration. Think of it like a timestamp, like 11 a.m. sharp. It's that exact moment a process pops into the ready state and basically says, hey, I'm here and I'm ready to go.
And before you even get in that line, you have a pretty good idea of how long your actual business is going to take with the teller. This is just the pure work part of your visit.
And in our world, that's called the burst time. Now here is the crucial difference. Unlike arrival time, burst time is a duration. It's the raw amount of work time a process actually needs from the CPU, assuming it gets to work without any interruptions.
Okay, so we've got our starting point, and we know how much work needs to be done. Now we can zoom out and start to measure the process's entire journey, from the moment it walks in the door to the moment it leaves. So fast forward a bit. You've done what you came to do. You've got your receipt, and you are walking back out that door. The entire task is officially done.
This moment is the completion time. And just like arrival time, notice this is another specific point in time. So, if you arrived at 11 a.m., maybe you're leaving at 12 p.m. It's the timestamp that marks the very end of the journey.
This is the question that really defines your whole experience, isn't it? It's not just about the 15 minutes of work, but the total time you had to block out of your day just to be in that bank.
This total duration is what we call the turnaround time. It's the complete life cycle of the process inside the system. It covers everything, all the waiting, all the working, the whole shebang.
And the calculation for this is perfectly logical. It's simply the completion time minus the arrival time. So if you left at 12 p.m. and arrived at 11 a.m., your turnaround time was 1 hour. Simple, but incredibly powerful.
Now, this is where it gets really interesting. That 1 hour of turnaround time wasn't all spent doing useful stuff. We can actually break it down into 2 very different parts: the time you were working and the time you were just waiting.
This is the key question that every system designer has to grapple with. We know the ideal work time, the burst time, was only 15 minutes, but the process was stuck in the system for a full 60 minutes. So where did that huge chunk of extra time just disappear to?
Yep, that's it. Those 45 minutes were just gone. Spent shuffling your feet, checking your phone, just waiting for your number to be called. It was time spent in the system, but it was absolutely not productive time.
And this gives us our waiting time. The important word here is total. See, sometimes a process gets a little bit of CPU time, then gets interrupted and has to go back into the queue. That time counts too. It's the grand total of all the period spent just waiting around.
And here's the formula that ties it all together beautifully. You take the total time you were there, your turnaround time, and you subtract the time you were actually working, your burst time. Whatever's left over, that's your total waiting time. So 60 minutes minus 15 minutes equals those 45 minutes of waiting.
Think about this moment for a second. It's a huge relief, right? It's the system's very first acknowledgement that it sees you and it's ready to start helping. That initial delay is a super critical metric, especially for systems that people interact with.
This is the response time. It measures how long it takes for the system to give you its first sign of life. It's not about finishing the job, it's all about starting it.
For something like a website or an app, a low response time is what makes it feel snappy and interactive.
Now, it is absolutely vital to not get these two mixed up. Response time is just that first wait, and it only happens once. Waiting time adds up every single second the process spends in the queue, even if it gets sent back there over and over. A process can have a great response time, but still have a terrible total waiting time.
Okay, so we've got all these individual metrics. Probably the best way to see how they all work together is to actually visualize a timeline of how a real CPU would juggle a bunch of different processes.
This is called a Gantt chart, and it's a really simple way to see what's happening over time. From left to right, we're tracking time in seconds. The chart shows us exactly which process the CPU is working on at any given moment. So for example, from time 0 to 3, it's all about process P1. Then at time 3, the CPU switches over to P2. But look what happens to P2. It runs from second 3 to 6, but then it comes back later at second 12. That huge gap from second 6 all the way to 12, that was all waiting time for P2.
So we've defined all these different kinds of times. Why did we even go through all this? What's the point of measuring these things so precisely?
Well, it all comes down to performance. You can't build a fast, efficient operating system if you have no way to measure it. These 6 metrics are the fundamental tools that engineers use to compare different scheduling algorithms and actually prove that one is better than another.
All right, let's lock in the key takeaways from all this. Arrival and completion, those are specific points in time, like timestamps. Burst, turnaround, waiting, and response, those are all durations or lengths of time. Just remember, turnaround is the total journey. Waiting is all that non-productive time, and response is that crucial measure of how fast the system feels at first.
And that leaves us with a really interesting final thought. Now that you can measure performance, how would you design the fairest or the fastest scheduling system? What if your goal was to minimize waiting time? Or what if you just wanted to guarantee the fastest response time? These metrics, they're the building blocks. The next step is using them to create and analyze the algorithms that literally run our modern world.